Lesson 15.1, Task 2. Investigate the relationship between arc length and radius. Recall that the radius of a circle is the distance from the center to a point on the circle, and an arc is a portion of the circumference of a circle. The diagram shows three circles with radii 1 unit, 2 units, and 3 units centered at the origin. A central angle of 200 degrees creates arcs ABC, DEF, and GHI between the initial side and the terminal side. So you can see this is radius of 1, and it creates the arc with 1 unit here, ABC, and then 2 units. The radius of 2 units is D. I can't follow the line, DEF, and then if it has 3, a radius of 3, it gives us GHI. So that's just 3 arc lengths based on 3 different units or 3 different radius. All right, so it says, what are the similarities and differences of ABC, DEF, and GHI? Select all that apply. All right, so it says the angles are congruent. So does it look like each angle is equal? No, it looks like it gets a little bit bigger each time as the radius gets bigger. So the first one's not true. The arcs are intercepted by the same central angle. All right, that's true, because we're looking at this central angle here. A central angle is just an angle from the center of the circle. So since the initial side and terminal side both go to the center of the circle, this one is a central angle, so that one is true. And it says the arcs appear to be different lengths. That one's true, because as the radius gets longer, it looks like the arcs are longer. And it says the arcs begin and end at different initial and terminal sides. Nope. They all start at the same initial and end on the same terminal side. And the arcs are formed by negative rotation. No, we go through quadrants 1, 2, and 3, so it is a positive rotation. To be negative, remember it would have to go clockwise, which is negative direction through the different quadrants. All right, so it says compare the length of ABC, DEF, and GHI without any calculations. What do you notice about the relationship between the corresponding radius and the arc length? So the length of the arc increases as the radius increases. Okay? All right, so what is the ratio of the number of degrees in the central angle in the diagram to the number of degrees in a full circle? What does this ratio represent? All right, so if you look at this, it says this angle is 200 degrees. So if we want to figure out what the ratio is, hopefully you know that a whole circle has 360 degrees. So we're going to see what is the ratio. Just means basically we're going to reduce our fraction. So if we have, let's just use our calculator here. If we have 200 degrees and we divide that by 360, and then we can change that to a fraction, that will give us our ratio 5/9. So 200 degrees is 5/9 of an entire circle. This represents the portion of the full circle through which the central angle rotates. All right, so it says the length of an arc is the length of the portion of the entire circumference represented by the arc. What do each of the following calculations represent? All right, so circumference is 2 pi r. So we're going to do 2 pi radius times the portion of the circle. So remember, we're not doing the entire circle, we're just doing this arc length here. So we know that 200 degrees is 5/9 of the entire circle. So we're going to do times 5 circles. So you're still doing the same formula, 2 pi r circumference. We're just doing it times part of the circle instead. So if we do it for the first angle, it had a radius of 1. We get 10 pi over 9. If we do it for the second one, it had a radius of 2, so it's 2 pi r, and then times 5/9, which is 200 degrees out of 360, so that gives us 20 pi r. And then if we do 2 pi 3, this represents our radius of 3, so that was the largest of the 3 angles. So if you go back here and see, remember this one had a radius of 1, this one had a radius of 2, and this last one had a radius of 3. And so if we calculate each of those, we get this for the circumference with this radius measure for 200 degrees of that circle. Okay? All right, so it says find the ratio of the arc length to the radius of ABC, DEF, GHI. What do you notice? All right, so it says the ratios are equal. It was 5/9 each time, right? Because 200 degrees out of 360 is going to be 5/9. So the ratio of the arc length to the radius of all 3 is really going to be 10 pi over 9. Because this has a radius of 2, if I divide this by 2, it becomes 10 pi over 9. This has a radius of 3, so if I take this and divide it by 3, I still get 10 pi over 9. So the ratio is still going to be the same, even though it was a little different because for each one of them, the radius was different. All right, that's all for task 2. If you have any questions, let me know. Lesson 15.1, task 3. Convert between degree measure and radian measure. All right, so it gives you a picture here, and you can see this one has a radius of 1, okay? And we're still using the symbol theta to represent this angle measure. And then the side length of the arc is equal to 1. So this says degree equals 1 radian. All right, so previously you have worked with degree measures such as 360 degrees in a full circle and 180 degrees in a straight line or semicircle. And angles can also be measured using the ratio of the arc of the length S to the radius R of the circle on which the arc lies. Given the radian measure, so this means angle again, so the radian measure equals, so angle equals S divided by R. And you can see up here, S divided by R would be your radius measure. The diagram shows a unit circle, which is a circle centered at the origin with radius 1. And you will hear the term unit circle a lot in trigonometry, and the unit circle always has a radius of 1. That's important to know. The angle that creates an arc equals in measure to the radius is called 1 radian. On a unit circle, 1 radian is the measure of an angle that intercepts the arc of length 1. And again, that's indicated up here with a radius of 1 and the arc length of 1. So that would represent 1 radian. All right, so it says there are 360 degrees in a full circle, and the arc length of a full circle is shown to the circumference. So the side length of that, or circumference, would be 2 pi r. So there are 2 pi r divided by r, which equals 2 pi radians in a full circle. So in trigonometry, sometimes you will see radian measure used. So 2 pi is equivalent to 360 degrees. So 2 pi radians is the same as 360 degrees, just in 2 different forms. So it's kind of like having 1/2, and that's equivalent to 0.5. All right, so if you know this is fraction form and this is decimal form, these two look very different, but they're equal. So the same thing goes with 360 degrees is equivalent to 2 pi radians. So 2 pi is equivalent to 360 degrees. This is in degrees. This is in radians. Sorry, my pi symbol looks so sad. All right, so let's look at what this means. So it says, so if we have S equals 2 pi r, so there are 2 pi r over r equals 2 pi radians in a full circle. This gives a conversion factor of 360 over 2 pi. Well, if you reduce 360 divided by 2, that gives you 180 divided by pi. And this is in radians, okay? So when it asks you to convert between degrees and radians, there is a very simple formula that you have to know. So going from degrees to radians, you're going to multiply by pi over 180. And going from radians to degrees, you multiply by 180 over pi. All right, so it says convert each measure from degrees to radians or from radians to degrees. And this is one of your state standards. So this is something you will see often. And I use the little trick, do I need pi or am I getting rid of pi? And that's how I kind of determine which way. It's very easy to remember. So pi over 180 or 180 over pi. So if I'm going from degrees to radians, I need to add pi. So I'm going to multiply by 180 over pi. You can see right here, going from degrees to radians, I'll multiply by pi over 180. All right, so all I have to do is simply take this and type it in. So I'm going to do 15 divided by 180. 15 divided by 180. And again, I'm going to find the reduced fraction form of that instead of the decimal form. So that's 1/12. So that becomes pi over 12 because you keep the pi. In radian measure, it's in terms of pi. So pi over 12 or 1/12 pi. And same thing here. I would do 700 divided by 180. And I do math and fraction. And it's going to give me the 35 over 9 pi. Now, you may say, why am I dividing? This says multiplication. Well, remember, anytime you're multiplying two fractions, this has to be over 1, and this has to be over 1, and this has to be over 1. So what I'm doing is just multiplying across the top and then dividing by what's on bottom. Well, since I know I'm keeping pi when I go to radian measure, that's why I can just do 700 divided by 180 and then to reduce the fraction. Same thing here. I can do negative 315. And then I can do divided by 180. And it should be the same sign because it doesn't matter if it's in degrees or radians. Remember, the positive or negative determines which direction the angle rotates in. So this becomes negative 7/4 pi. So when I'm going from degrees to radians, multiply by pi over 180, keep the pi. Radian measure is in terms of pi. All right, going the other direction, we're going to do something very similar. This time we're going to multiply by 180 over pi. And the way I remember that, I want it to be in degree measure. So I'm going to get rid of pi. So if I multiply by 180 over pi, the pi's cancel. So all I have to do is reduce the fraction. So I've got here 180 over 3 is 60. That's easy. Here I've got to do, let's see. For the second one, I'm going to do negative 4 times 180 divided by 3. So negative 4 times 180, and then divide by 3. So that gives me the negative 240. For the last one, I'm going to do 11 times 180 divided by 6. All right, so it says y is a conversation factor with degrees in the denominator using when converted 15 degrees to radians. All right, and that's just the difference in going from adding pi or getting rid of pi. What do you notice about the signs of the angle? The signs are the same. The sign indicates the direction of rotation. All right, so I went through that last